'Tis the season to change your tires at Pep Boys. When it comes to holiday travel prep, your local Pep Boys has you covered. Buy 3 select tires and get the 4th one free, instantly. Pep Boys offers online booking, text alerts to track your service, and mobile payments to pay on the go to get you back on the road safely. Make an appointment at pepboys.com and don't miss out on these incredible deals. Offer valid through November 30th. Requires installation and additional fees. See store for details or visit pepboys.com to learn more.
Welcome, everybody, to Astronomy Daily for another episode. I'm Steve Dunkley, your host. It is July 3, 2023. Welcome aboard.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And welcome, of course, to Hallie, our co-pilot. How are you today, Hallie?
Doing just fine, thanks. Hello, everyone.
Well, it's been a big week. I've watched the Falcon 9 go up, taking new crew to the ISS, and that was exciting. Lots of interesting other things going on. How about it, Hallie?
Well, the Euclid Space Observatory is finally on its way.
To the far side of the sun, of all places.
Yes.
Where exactly?
To the Sun-Earth Lagrange Point 2 position, looking for dark matter.
Oh, of course, that's where they'll find it. And I'll be chatting about TESS and the discovery of a couple of Earth-like exoplanets.
I love exoplanets.
Really? You always push them to the side of your plate. I had no idea.
And I've got some Artemis news about their Canadian astronaut Jeremy Hansen.
Oh, don't tell me he's joined Space Force.
Don't be silly. And you've got a really interesting story about gravitational waves, haven't you?
Oh yes, exoplanets are big news these days. And also, they've caught up with that little helicopter on Mars that they lost communication with after 63 days on its lonesome. So I can't wait to find out about that. And you're going to tell us about that one.
That's right. I'll get on with it now. Here's the short takes. A new space observatory is flying across the void after a dramatic launch atop a SpaceX rocket last Saturday, July 1st. But its journey has just begun. The European Euclid Space Telescope began its long journey to deep space on a SpaceX Falcon 9 rocket from Cape Canaveral Space Force Station on Florida's Space Coast. Oh, Steve, you should be playing the Space Force music.
Hang on, got it.
European Space Agency Director General Joseph Aschbacher said it was really a fantastic launch, from the insertion of the spacecraft into orbit separation. But he said researchers are anxious to the point where the various instruments are being switched on will take a couple of weeks. The Euclid Space Observatory will now spend the next month commuting to the Sun-Earth Lagrange Point 2, which is about 1 million miles (1.5 million kilometers) away from our planet on the opposite side of the Sun. Next comes a complex sequence of tests and observations to make sure its 2 instruments are ready to go before it is cleared for its ultimate mission, to find evidence of invisible dark matter and dark energy and how it is shaping our universe. Canada's Artemis II astronaut Jeremy Hansen says his country is just getting started in lunar realms with his round-the-moon mission. He says that a Canadian will walk on the moon one day. Hansen was named Canada's representative on Artemis II on April 3rd. And within days the experienced test pilot found himself exploring new worlds as a result, speaking with Stephen Colbert, walking the red carpet at Guardians of the Galaxy Volume 3, participating in an Indigenous Vision quest, visiting policymakers in Canada and the US, and carrying the flag at the coronation of Charles III. After this work to connect with numerous communities touched by space, the Artemis II crew officially began training on May 15, studying the control systems and computers of the Orion spacecraft and other technical matters. In a few months, however, the training timeline gets a little fuzzy, as this will be the first moon crew in a half-century. The crew is awaiting direction, as well as the development of simulators and procedures, from senior management. For developmental missions, that's to be expected, Hansen said. Eventually, you'll see us doing amazing science and deep space, Hansen said. You'll see a Canadian walk on the moon someday, and eventually go to Mars, because we have that ability to do it in a way that brings benefits to Canadians. The Canadian Space Agency has suggested that Canada will have seats on Artemis 4 and 6. Which are both planned moon landing missions slated for around the end of the decade. CSA's Director of Space Exploration Development Martin Bergeron disclosed those early-stage discussions at the Canadian Lunar Workshop in late May. The first landing mission Artemis 3 may be in 2025 or 2026. The 52nd flight of NASA's Ingenuity Mars helicopter is now in the official mission logbook as a success. The flight took place back on April 26, but mission controllers at NASA's Jet Propulsion Laboratory in Southern California lost contact with the helicopter as it descended toward the surface for landing. The Ingenuity team expected the communications dropout because a hill stood between the helicopter's landing location and the Perseverance rover's position, blocking communication between the two. The rover acts as a radio relay between the helicopter and mission controllers at JPL. In anticipation of this loss of communications, the Ingenuity team had already developed recontact plans for when the rover would drive back within range. Contact was re-established June 28 when Perseverance crested the hill and could see Ingenuity again. The goal of Flight 52, a 1,191-foot, 363-meter, and 139-second-long flight, was to reposition the helicopter and take images of the Martian surface for the rover's science team. The portion of Jezero crater the rover and helicopter are currently exploring has a lot of rugged terrain, which makes communications dropouts more likely, said JPL's Josh Anderson, the Ingenuity team lead. The team's goal is to keep Ingenuity ahead of Perseverance, which occasionally involves temporarily pushing beyond communication limits. We're excited to be back in communications range with Ingenuity and receive confirmation of Flight 52. 63 days is a long time to wait for the results of a flight, but the data coming in indicates all is well with the first aircraft on another world. If the remainder of Ingenuity's health checks are equally rosy, the helicopter may fly again within the next couple of weeks. The target for Flight 53 is an interim airfield to the west, from which the team plans to perform another westward flight to a new base of operations near a rocky outcrop the Perseverance team is interested in exploring. And that's all from me for now. Back to you, Steve.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
And once again, thank you for joining us on Astronomy Daily. I'm Steve Dunkley, your host, and you can catch all the past episodes of Astronomy Daily at spacenuts.io, and you can catch all the past episodes of Space Nuts, our parent podcast with Andrew Dunkley and Professor Fred Watson at that same address. Astronomers have found a second Earth-sized planet in an intriguing alien solar system. NASA's leading planet-hunting spacecraft has spotted its second planet that matches Earth size and may be able to retain liquid water, and both worlds orbit the same star. NASA's Transiting Exoplanet Survey Satellite, TESS, launched in April 2018. Since then, the mission has discovered 285 confirmed exoplanets and more than 6,000 candidates. One of the most intriguing of the confirmed planets is a world dubbed TOI 700d, which is about the size of Earth and located in its star's habitable zone. Now, scientists have determined that the planet has a neighbour that's just as tantalising, thanks to an October 2021 alert that the Earth orbiting telescope has seen something interesting. Emily Gilbert, an astronomer at NASA's Jet Propulsion Laboratory in California, told Space.com, "We first started looking at it and we're like, is this real?" Gilbert and her colleagues are presenting the research at the 241st meeting of the American Astronomical Society being held this week in Seattle and virtually. She was very excited, and the timing helped too, because in keeping with the birthday theme, it was the day before her birthday. TESS finds planets by staring at stars for a month at a time, looking for small dips in brightness that can indicate a planet passing between the star and the telescope. From these dips, astronomers can estimate the size of a planet and clock its orbit. In 2020, Gilbert and her colleagues reported the discovery of 3 planets around a small star called TIO 700. TIO stands for Tess Object of Interest, which is located about 100 light years away from Earth. That star is a red dwarf, but unlike many of its siblings, TIO 700 is relatively quiet, without the sudden pulses of activity that could fry any life on a nearby world. In the full 2-year data set that we have from TESS, she says, we see no evidence of optical flare. 2 of the 3 planets the TESS initially found in the TIO 700 system orbit too close to the star to look much like Earth, but the third world, known as TIO 700D, is particularly tantalising. That the world scientists found is about 20% larger than Earth and orbits the star every 37 days, putting it in what scientists called the habitable zone, where temperatures would allow liquid water to exist on the surface. TESS will have its eye back on TIO 700 in just over a week, Gilbert noted, with another 9 months or so of data due within the coming year, and researchers have brought in reinforcements as well. Gilbert is currently observing the system with the Very Large Telescope in Chile, using its shell spectrograph for rocky exoplanets and Stable Spectroscopic Observations (ESPRESSO) instrument, which is designed to characterise Earth-like exoplanets. The researchers hope the ESPRESSO observations will allow them to determine the masses of all 4 planets in the system, and a collaborator is using the Hubble Space Telescope to estimate the star's ultraviolet emissions, information that could inform climate models for these planets. And although the James Webb Space Telescope has already proven capable of sniffing out the components of an exoplanetary atmosphere, that skill won't be used on either TIO 700D or E, which are each small enough that an atmospheric analysis would take far too long to be practical given the star's small size, Gilbert says. However, it might be able to study the largest planet, TIO 7b, she added. If the star was a little closer or a little bigger, she said, we might have been able to spot TIO 7e in the first year of Tess's data. Ben Hord, a doctoral candidate at the University of Maryland College Park and a graduate researcher at NASA's Goddard Space Flight Center in Maryland, said in a statement, but the signal was so faint that we needed the additional year of a transit observations to identify it. Now, scientists have finally heard the chorus of gravitational waves that ripple through the universe. Scientists have observed for the first time the faint ripples caused by the motion of black holes that are gently stretching and squeezing everything in the universe. They reported Wednesday that they were able to actually hear what are now called low-frequency gravitational waves, that is, changes in the fabric of the universe that are created by huge objects moving around and colliding in space. It's really the first time that we have evidence of just this large-scale motion of everything in the universe, said Moira McLaughlin, co-director of Nanograv, the research collaboration that published the results in the Astrophysical Journal Letters. Einstein predicted that when really heavy objects move through space-time, the fabric of our universe, they create ripples that spread through that fabric. Scientists sometimes liken these ripples to the background music of the universe. In 2015, scientists used an experiment called LIGO to detect gravitational waves for the first time and showed Einstein was right. But so far, those methods have only been able to catch waves at high frequencies, explained Nanograv member Chiara Mingarelli, an astrophysicist at Yale University. Those quick chirps come from specific moments when relatively small black holes and dead stars crash into each other, Mingarelli said. In the latest research, scientists were searching for waves at a much lower frequency. These low ripples can take years or even decades to cycle up and down, and probably come from some of the largest objects in our universe, supermassive black holes billions of times the mass of our Sun. Galaxies across the universe are constantly colliding and merging together as this happens, scientists believe, and the enormous black holes at the centres of these galaxies also come together and get locked into a dance before they finally collapse into each other, explained Boltzmacher, an astrophysicist at Columbia University who was not involved in the research. The black holes set off gravitational waves as they circle around in these pairings known as binaries. Supermassive black holes, binaries, slowly and calmly orbiting each other, are tenors and bass of the cosmic operas, Marker said. No instruments on Earth could capture the ripples from these giants, so we had to build a detector that was roughly the size of the galaxy, said nanograv researcher Michael Lamb of the SETI Institute. The results released this week include 15 years of data from nanograv, which has been using telescopes across North America to search for the waves. Other teams of gravitational wave hunters around the world also published studies, including in Europe, India, China, and Australia. The scientists pointed telescopes at dead stars called pulsars, which send out flashes of radio waves as they spin around in space like lighthouses. These bursts are so regular that scientists know exactly when the radio waves are supposed to arrive on our planet, like perfectly regular clockwork. But as gravitational waves warp the fabric of space-time, they actually change the distance between Earth and these pulsars, throwing off that steady beat. And by analysing these tiny changes in the ticking rate across different pulsars, with some pulses coming in slightly early and others late, scientists could tell that the gravitational waves were passing through. So far, this method hasn't been able to trace exactly where these low-frequency waves are coming from, said Mark Kamiankowski, an astrophysicist at Johns Hopkins University who was not involved with the research. Instead, it's revealing that the constant hum that is all around us, like when you're standing in the middle of a birthday party, and there's our birthday theme again, you'll hear all of these people talking, but you won't hear anything in particular, he said. At any rate, they're hoping that continuing to study this kind of gravitational wave can help us to learn about the biggest objects in our universe. It could open new doors to cosmic archaeology that may track the history of black holes and galaxies merging all around us. Now, considering it's my birthday on Friday, I thought I'd have a look back at what sort of things were going on during my lifetime. And looking at 38 years ago on this day, or within this day, on July 2 in 1985, it was the turn of space probe Giotto to be launched toward Halley's comets. So, Hallie, you'd be all over that, wouldn't you? I don't think you were invented then. On July 2, 1985, the European Space Agency launched Giotto space probe to get a close-up look at Halley's comet, and I do remember this one. Nearly 9 months after the launch on March 14, 1986, Giotto became the first spacecraft to observe a comet close-up as it flew by. Halley's comet came within 370 miles, in the old language, of the comet's surface. Giotto was named after the early Renaissance painter Giotto di Bordone, who had depicted Halley's comet as the Star of Bethlehem in his painting Adoration of the Magi. I can't believe that's 38 years already. And just like that, that's how this little universe comes to an end. Another episode of Astronomy Daily done and dusted. Thanks for joining us. I'm Steve, your host, and don't forget Tim on Fridays, Andrew and Professor Fred on Space Nuts. You can hear all the episodes of both podcasts on spacenuts.io anytime you like, and join them in the car or while you're walking or jogging or yogging, as they say in Sweden. Is that true or not? I'm not sure. Anyway, see you later, Hallie.
See you all next time.
Over and out.
Astronomy Daily, the podcast, with your host, Steve Dunkley.